Hello, my name is David Shaw. I'm here to talk about the LVTGO-VBS low voltage EMC standards and robustness test system. I'm here today to talk about some more advanced features of the system, for example creating CSV waveforms and delivering them to devices under test, and also a little about how to log and analyse data. Let's get started. The LVTGO system comes pre-programmed with a number of default waveform types that simulate common supply disturbances. These can be found on the opening screen of the LV test suite. Many of these waveform types are divided into segments, whose voltages and durations can be randomised around values you can configure. The system can then deliver many thousands of slightly different waveforms to a device under test in a repeatable manner. However, if you would rather deliver a bespoke voltage profile, this is easily achieved. To do so, simply select Captured Waveforms from the main menu of the LV test suite. From here, we'll see a screen displaying live output setpoint. Of course, we're not delivering a waveform yet, so the output is a steady 12 volts. To select a custom waveform to play, we need to hit Captured Import. There now follows a three-stage process. First, your CSV file is uploaded into LV test. Next, it's resampled so it's compatible with the LVTGO. Finally, it's downloaded to the LVTGO where it's stored in memory, ready to be delivered. Let's see how this is done. If we click Import CSV files, we can select from a few pre-prepared datasets. These are actually starting waveforms from production vehicles. If we open one of these files up, you can see that they consist of simple pairs of values. Once we've imported our custom waveform, we can move to the Captured Resample screen. Here, we'll be able to select our waveform on the left, click Resample, and in a few moments a resampled file will be generated. Finally, we move to the Captured Transfer screen. If we click Connect and Sync, the software shows all waveforms currently held in the LVTGO's memory. Then, if we select our sampled waveform and store, our waveform will be transferred to the LVTGO hardware, ready for playback. Having successfully loaded our captured waveform into memory, we can now return to the waveform main screen. Under waveform number, we just need to enter the number corresponding to our new waveform's position in memory, click play, and our captured waveform will start. You should note that it's also possible to see the voltage and current actually being generated. Should you wish to log a waveform being delivered to a device under test, that's also possible. To show you how this is done, we'll start to deliver a random cranking waveform to our device. On the right-hand side of the waveform main screen, you'll notice a data logging option. We'll select wave only for now and play our waveform. As you can see, logging begins automatically and ends once playback is cancelled. Once playback has ended, we can click Save Clear Log Data to save our profile. To analyse this data, we need to select the LV Test tab at the base of the screen. Here, we'll find our file under Related Documents. If we open this up, we can see a graph of the waveform we delivered. We can manipulate this data here, or if it's more convenient, export it as an image or CSV file. An important final feature to touch upon is triggering. If you're looking to automate your testing, the LV test suite can be triggered by a CAN bus or a digital signal, or can send these triggers on completion of a particular activity, such as reaching a certain time step. Settings for triggering can be found within the triggering screen of the LV test suite, both for output and input triggering. More advanced test automation can be configured using COM interfaces. That's it for now. If you have any other questions about the LVTGO, why not get in touch with us via our inquiries address info@add2.co.uk or give us a call. We hope to hear from you soon.